Thank you, Chen, and good morning, everybody. Again, my name is Francesco Cafaro from Indiana University, Purdue University, Indianapolis, and I'm presenting this work on behalf also of two co-authors, Leilah Lyons and Alissa Antle. As Chen mentioned, the title of this work is Framed Guessability, and Framed Guessability is a new methodology that we introduced to improve the discoverability of gestures and body movements for full body interaction. Well, let me clarify since the beginning what I mean with full body interaction in this presentation. With full body interaction, I refer to all those interactive systems and installations that are no longer controlled using a traditional input device, such as a keyboard or a mouse, but directly through the gestures and the body movements of their users. Well, full body interaction is not that new. This screenshot looks very much like a modern Kinect application, but is actually taken from Video Police, an installation that was created in 1975 by Myron Kruger. And Video Police allowed two people who were in different rooms to interact with each other and used a layout of the space that resembled very much the layout of modern Kinect installation. Well, even though full body interaction is not that new, it has been confined through the wall of research labs for a very long time, at least until the recent availability of mobile commercial tracking technologies like the Nintendo Wii and the Microsoft Kinect. And even with this this commercial technology haven't had the wide adoption that we all originally expected, up to the point that last year Microsoft decided to kill the Kinect. Well, we believe that part of the problem with gestural interaction lies in the way in which gestures and body movements are currently designed. So traditionally, gestures and body movements have been designed by groups of designers, generally using sets of kinesthetic guidelines, but it is very hard to make sure that what designers have in mind is then also intuitive for the users of these actual systems. Guessability studies are an alternative approach. Guessability studies, as defined by Wearable and then by Morris, are an alternative approach in which groups of potential users are exposed to some functionalities of the system, and without receiving any contextual information on what the system is supposed to do, users are asked one at a time to recommend the gestures for controlling the functionality of the system that they're exposed to. And then using a sort of majority voting, the gestures that is recommended the most, the gesture that is recommended by the biggest pool of users for that specific functionality is the one that is then implemented. Well, one of the problems with this approach is that it may generate gestures and body movements that are disconnected with each other. This is an example of from an elicitation study that was done in order to design gestures for smart TVs. And at the end of this study, what people recommended was to move the hand to the left to move to the next channel, draw a letter M to open a menu, or perform a sort of hand wave to hide the menu. Well, move hand to the left, draw letter M, hand wave, they're pretty disconnected gestures. And this means that even if the user of this system is able to discover one of these gestures, well, discovering one gesture is not going to help with discovering any of the next ones. So the original question that we had was, how can we improve the discoverability of gestures and body movements by eliciting gestures and body movements that are somehow connected with each other? And in order to do that, we decided to incorporate frames into the elicitation process. Frames were originally defined by Phil Moore in the context of linguistics They have been also incorporated by Lakoff in the theory of embodied schemata. And basically, frames are conceptual structures that we use to structure some patterns of our everyday life. So for example, if I say the word restaurant and show you this picture, you probably imagine a scenario in which you are sitting at a table, somebody takes your order, you're getting some food. You do not expect, for example, that at some point while you're eating, a doctor runs into the room, into the dining area, gives you a scalpel, and asks you to operate some surgery on his patient. This is just not what seems to be reasonable in this scenario. So frames are also useful to limit what is reasonable in a specific situation, in a specific context. So frame guessability is the methodology that we introduced, and is structured in two phases. The first phase is a priming phase, and during this priming phase, we prime people with a scenario. And immediately after priming people with a scenario, we perform an elicitation study in which we ask the same person to recommend gestures and body movements for functionalities of our interactive installation. And the scenario that we used for this study was an interactive installation that we were designing for the New York Hall of Science. The New York Hall of Science is a medium-sized science museum in Queens, New York. And in this interactive installation, we were representing some data from the US Census. For example, in this screen, we showed some scale bubbles that represent the number of people who identify themselves as German on a map of New York. And we wanted to make this installation interactive and engaging for people. So for example, one of the we implemented some functionality. This is one example in which we changed the aggregation of the data from census tract to city level. But long story short, what is really interesting in this scenario of interacting with data is that there isn't a well-known structured way to control these functionalities. So human-data interaction, designing the interaction with data, was a very good scenario for testing out frame guessability. And in order to test frame guessability, we perform some preliminary work in lab using 3 experimental conditions. This is work that was done with 89 participants at the University of Illinois at Chicago. We asked participants to recommend gestures and body movements using frame guessability under 3 experimental conditions. One that we call fun house, the other one gym, and the last one was a control condition. Well, in the fun house condition, people were primed with being at a fun house in front of a distorted mirror. In the gym condition, people were primed with exercising at a gym using a weighted ball. And in the control condition, we just didn't do any priming. So we moved people immediately to the elicitation phase. Again, frame guessability is structured in 2 phases, priming and elicitation. The first phase is priming. And the way in which we performed the priming was using a combination of a visual priming. Basically, we are showing a slideshow of pictures that we thought were evocative of that scenario when a person was entering the lab. Then we perform a written task in which we are asking people to write down things that gestures, body movement, or other things that they would normally do in that scenario. And then we ask people to reenact something that we call embodied priming. We ask people to reenact the things that they listed in front of the screen. And these are 2 examples of what people reenacted when they were in the funhouse condition versus when they were in the gym condition. Again, this is something that happened during the priming. The second phase of Framed Guessability is the actual elicitation study. So after the priming, we were showing the functionality of our system to each person, one at a time, and we were asking people to recommend gestures and body movements for each functionality of the system. So for example, in order to control the transparency level of the data, this is what one person recommended during in the funhouse condition, moving back and forth. This is what another person recommended in the gym condition instead, squatting up and down, which again, they're pretty different gestures. And this is what an additional person recommended in the control condition. The control condition is the one without any priming, closing your hand and opening your hand. Well, what we actually wanted to do was to figure out if these different sets of gestures and body movements that we were able to create with the Framed Guessability were then relevant in terms of the discoverability. So if Framed Guessability had an actual impact on the discoverability of gestures and body movements. And in order to do that, we performed an in-situ study with 138 museum visitors at the New York Hall of Science. What is particularly important here is that we didn't prime people with any of the frames that we used in lab. So basically, participants were able to interact with 3 different implementations of the systems, and they just had to guess how to make the system work. They were able to freely be in the space and try to figure out how to make the system work. Well, what we observed is that when we look at the number of gestures and body movements that people were able to guess in each experimental condition in situ, even without any sort of priming, in the control condition, the number of gestures and body movements that people were able to guess peaks at 2 and fades out at 3 or 4. In both Framed Guessability condition, this number peaks at 3 and fades out at 4 or 5. And in particular, when we perform a statistical analysis, what we observed is that at a session level, if we consider groups of people that were interacting with the system, the funhouse condition was significantly better than the control condition in terms of the number of gestures and body movements that people were able to guess. And also at a user level, if we just look at each single user of the system, the funhouse condition and the gene condition were both better than the control condition in terms of the gestures and body movement that each single user was able to figure out by himself or herself. Something else that was particularly surprising for us is to observe how familiar gesture doesn't necessarily mean that those gestures are also discoverable. For example, in the traditional guessability condition, in the control condition, the gesture that was recommended the most to increase and decrease the size of the bubbles, of the data bubbles, was a pinch and zoom gesture, pinch and zoom gesture that we are all familiar with because of our daily interaction with mobile phones. Well, when we move to the in-situ experiment, only 1% of the actual users was able to come up with this gesture in the control condition to operate the system, which probably means that some of these gestures that we are already familiar with do not work as well when we are in front of an interactive system, so of a full body system, which means in turn that what seems to really matter is not how familiar we already are with a gesture, but how we can create gestures and body movements that are somehow connected with each other. And what I presented today is exactly a new methodology, Framed Guessability, that uses a priming phase and an elicitation phase to create gestures and body movements that are somehow connected with each other. and that proved to be more discoverable in situ than those created with traditional elicitation studies. And this concludes my presentation, so thank you all for your attention.
Oh, we have time for a couple questions.
Hello, I'm Christine Dirk from University of California, Berkeley. Great talk. I'm curious how you picked the frames.
Christine, very good question. This is a fantastic question, and it's something we've been working with also recently. Well, the original idea that we had was to pick something that we expected was going to generate mostly hand gestures or more static poses, which is the fun house. In front of a mirror, you usually don't do very hardcore gestures like jumping or spinning around in front of a mirror, versus a situation like the gym in which people are usually more prone to use full body movements. We wanted to test out these two conditions. Now, these two conditions were completely disconnected with the actual content of our exhibit. So there is more work that needs to be done on figuring out which are the elements of the frames that make a frame particularly effective for a particular type of technology, for example, big screen versus pure projected display or a tangible interaction.
Great, thank you.
Hello, Das from IDC Herzliya. Very interesting. In the priming experiment, did you have different variants between the priming conditions and the baseline condition? I mean, did the baseline condition had different gestures in the elicitation while the priming were more similar?
That's a very good question. I should actually go back to the data to look at the variance. It seems to me that from what I remember, again, I should go back to the data to give you a precise answer offline. But it seems to me that there was more variance in terms of user agreement, also in terms of which gestures and body movements were the most recommended for each functionality of the system. Using a context, providing people with a context during the elicitation phase was able to slightly increase the agreement on what people were recommended. And I can follow up on this. Something else that we found pretty interesting is that when we were not providing people with a frame, with a context, so when we were in the traditional guessability condition, in the control condition, people were basically coming up with scenarios by themselves, like, yeah, I think this is like playing a board game, or I think this is like playing soccer ball. And these scenarios that were all disconnected with each other, so they were generating gestures and body movements that were not coherent.
Thank you.
Hi, Vikram Mehta from the Open University UK. Thank you for the talk. I have actually two questions. So first one is that is this methodology also applicable for designing interactions on body? So you talked about gestures and then body movements, but what about on-body interactions?
Can I ask you to specify what you mean with on-body?
So on-body, like interacting with the skin, basically. So there are many advances in that area as well, so interacting with the skin and body.
Yeah, it's a fantastic question. It's a good follow-up that can possibly be done because, as you mentioned, most of this work, all of this work, at least so far, has been done with full body interaction and with a specific type of full body interaction, which is putting people in front of a big sheer screen that looks pretty much like this projected screen in a museum. Now, we all know there are so many possible ways to interact using gestures and body movements that are not confined to just interacting with a big screen like this. So I think this all connects with the question that Christine asked at the beginning on how we can pick the frame. I think there is more work that needs to be done on figuring out which is the best way to prime people depending on the type of technology that we are using. But for sure that it is very relevant for future work.
Okay, so the second quick question is that you refer to Warburg and they used to calculate agreement scores for determining the gesture. So do you also do something similar, or is there any measure that picks the best gesture, or is it purely customizable for each person?
Absolutely, absolutely. Very good point. And that's exactly what we did. I mean, if you want the full details are in the paper in terms of the agreement rate for each of these gesture and body movement that were recommended. We also did some work, it was presented at TI a few years ago, in which we were trying to figure out if priming people was actually effective in terms of increasing the agreement in lab, and that seemed to be the case as well. The reason why I didn't go into the details of the agreement in this presentation is because I wanted to focus on the discoverability. So the focus of this work was mostly on trying to see what happens not in lab, not just with a measure of agreement, even though a measure of agreement is usually a very good proxy for how intuitive a gesture or body movement is, at least this is how it has been considered. But I wanted to really test out the results of this methodology in situ and see if, besides the agreement, the increase on the agreement also had an impact on the increase of discoverability.
Thank you very much.